storm. That broadcast storm is referred to as a bridging loop or a switching loop. But not only is that going in this direction, but it's also going in this direction, because keep in mind, when that hub first received it, that first broadcast, it not only sent it to switch 1, but it sent it to switch 2 at the same time, so it's a loop going this direction and a loop going that direction at the same time. This broadcast storm will eat up all the bandwidth and will shut the network down. This is one of the problems that occurs because of a redundant topology. Another problem that we have with redundant topology is the problem of multiple frame copies. Multiple frame copies. Say, for instance, device A is sending a frame to device B over here. Sends out this frame, it hits the hub repeats it. That frame goes to device B immediately, so device B has a copy of that frame, but at this point, the hub also sends it to switch 1. Switch 1 right now does not recognize the destination address, does not have the destination address of device B as of yet. So what switch 1 does is flood. Sends it out to the hub gets it, the hub repeats it, goes to switch 2. Switch 2 at this point still does not have the destination MAC address of device B, and of course it will flood. That means it'll go out onto segment 1 again, hit the hub being a dumb device will not recognize the fact that I've already sent this frame over to computer B, and will send a second copy of that same frame to the PC here, to computer B. This is not a problem with some applications, but many applications won't tolerate this type of multiple frame copies. Say, for instance, we're doing heart monitoring on the network. Well, you wouldn't want a second copy of the same frames going across that hospital's local area network. Or say, for instance, we're doing streaming video. Well, if that happens, then it's going to be a second copy of that same information going over to this device. So, the first problem that we talked about because of redundant topology is broadcast storm. The second problem that we talked about is multiple frame copies. The third problem is what we refer to as MAC database instability. Remember, the switch keeps a MAC address table, and the switch associates the MAC address. We'll simplify the MAC address of device A by simply saying AA. The switch associates the MAC address of a particular device with the port that it came in on. So, device A sends a frame to device B here. Well, initially the switch's MAC address table is empty, so the switch sees B in the frame. We'll write a copy of the frame here. The frame looks like this, just so we keep track of it. Here's the source address, here's the destination address. The switch looks at this destination address and compares it to the entries in its table. Right now, though, the switch does not have any entries in the table for B. So therefore, if it does not recognize the destination address here, what do switches do when they don't recognize the destination address? They flood, which means the switch will flood that out onto segment 2. At the same time, though, the switch takes the source address information and plugs it into the table and says, okay, well, I do know where device A is. Device A is attached to port 1 here, and so in the MAC address table, I'm going to associate device A with port 1. So at the same time, though, this frame, being that it hit the hub here, it goes to switch 1, but at the same time it went to switch 2. Switch 2 gets that frame and does the same thing. Switch 2 says, well, device A is on my port 1, and floods the frame out onto segment 2. Well, switch 1 flooded that out onto segment 2, and that frame hit switch 2 a second time, and now switch 2 looks at the source address and says, oh, well, okay, is device A on port 2 now? And so it thinks that device A is on port 2. This is an unstable situation. This is MAC database instability. And so the switch doesn't know which of these actual ports to associate with this source MAC address. And actually what the switch does is it overwrites each time that there's a new frame that comes in. This is called MAC database instability. So the thing to keep in mind here is that with redundant topologies, in spite of the fact that redundant topologies are a great thing and a very necessary thing, redundant topologies can create problems. They can create broadcast storms, multiple frame copies, as well as MAC database instability. Now, let's take a look at how to fix this problem. The solution to the problems that we run into with redundant topology is spanning tree, also referred to as STP. Spanning tree is going to provide a loop-free redundant topology by placing one of the ports in blocking state. So we've got two segments here. I'm going to simplify this. Remember, even though this looks like just a wire, this is actually that hub right there. Here's segment 1, segment 2. Here's switch 1 and switch 2. What spanning tree does is it produces a loop-free redundant topology by placing certain ports in blocking state. So what spanning tree will do is spanning tree will block one of these ports so that now there's only one path, one active path between segments 1 and segment 2. Spanning tree does this by electing what's referred to as a root bridge. A root bridge.